To more completely explain each of the generic methods for 3D geometry representation, let's examine an example geometry and then mathematically describe it each way. The geometry for this example will be a simple box, or in the language of 3D images, a cuboid. Our box will be 2 meters in height, 2 meters in width, and 2 meters in length. In addition to the information that describes the object itself, information is also required to define where that object is in 3D space. For our example, we will assume that one corner of the box is on the origin of a Cartesian coordinate system, and that box extends into space in the directions of the positive x-axis, positive y-axis, and positive z-axis. Using the geometric primitive method, the parameters we need to describe our box include location, size, and orientation. Mathematically, we could describe the box as a cuboid where x equals 1, y equals 1, and z equals 1, with x, y, and z being the Cartesian coordinates of the center point. We would also have L equals 2, h equals 2, and w equals 2, with L, h, and w being the length, height, and width, respectively. Finally, we would have r equals 0, with r being rotation, and I equals 0 with I being the inclination. To describe this same box using the extrusion method, we need slightly different parameters. We need to define Cartesian coordinates for the polyline that will be extruded, a vector to extrude the shape in the direction of, and a distance to extrude it. We could describe our 2x2x2 box as an extrusion where polyline PL equals 4 points, with the first point being 0, 0, 0, the second point being 0, 2, 0, the third point being 2, 2, 0, and the fourth point being 2, 0, 0. V would equal 0, 0, 1, where V is the direction vector, and D would equal 2, where D is the distance to be extruded. The revolution method would not be recommended to create a box due to its lack of rotational symmetry, but the method would be perfect for creating a cylinder. To create a cylinder using the rotation method, we can define a rectangle by its coordinates, then specify a line to rotate the rectangle around, then specify an angle of rotation. For example, to create a cylinder with a radius of 1 and a height of 2 centered on the x-axis, we can start by specifying the coordinates of the starting rectangle. In this case, the coordinates would be 4 points, with the first point being 0, 0, 0, the second point being 0, 1, 0, the third point being 2, 1, 0, and the fourth point being 2, 0, 0. Again, we use 3D coordinates, so we can place this 2D surface anywhere in 3D space. Next, we need to define a line to rotate the object around, or an axis of rotation. To represent a line in 3D space, we can use the parametric equation, which defines a point that the line passes through, and a vector which represents the direction of the line. The angle of rotation is simply how far around the axis of rotation you wish to rotate the polyline. If a full rotation is desired and units of degrees is used, the rotation would be 360. We can write our cylinder mathematically as a revolution where polyline PL equals 4 points, with the first point being 0, 0, 0, the second point being 0, 1, 0, the third point being 2, 1, 0, and the fourth point being 2, 0, 0. P equals 0, 0, 0, where P is a point on the axis of rotation, V equals 1, 0, 0, where V is the direction vector of the axis of rotation, and R equals 360, where R is the angle of rotation.